Hi everyone, thank you so much for joining. We'll just wait for some more seconds and we will start. Meanwhile, our speakers can share their screen, and thank you everyone for joining in. Spanna, you able to share your screen?
Yeah, just give me a minute, Yukti.
No worries, no worries. So, hi and welcome everyone to our webinar, Building Fast Gen AI Apps on Mongo Data with SingleStore Kai. My name is Yukti and I will be your moderator today. One of my main jobs here at SingleStore is to organize weekly AI webinars. We aim to have 2 webinars per week. So we demonstrate different data and AI use cases, new tools and technologies. I also post about our upcoming webinars here and now. So if any of these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in loop. And I'll also like to hear your feedback or ideas on topics that you would like to see in future sessions. So please feel free to drop in a message to anyone on the team, and we'll get back to you. So speaking of future sessions, we have multiple informative new webinar sessions that are coming up. Can we please go to the next slide? Yeah, thank you so much. So on August 5th, we have the August 1st webinar has been rescheduled. That will be scheduled on 16. That will be communicated very soon for anyone that has registered and is attending this webinar. On August 5th, we have Trillion Row Cloud DB speed test. And on August 7th, we will be presenting Elevate Your AI Apps with Database Branching. And if any of these topics are interesting to you, please RSVP right now. And I hope to see you all there. Coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to try to answer 100% of the audience questions, even if that means following up with folks afterwards via email to take those questions offline. So just make sure you ask away no matter what your question is. Just make sure that you have logged into Zoom with your name and email address, because we will not be answering any anonymous questions. So we'll also like to hear for you all to have a dynamic experience during this webinar. So feel free to try out SingleStore notebooks. Anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice. Simply click the link that is present on your screen. So, Spandana, can you please go to the next slide, which contains the raffle? Yeah. So it's there on your screen. You can click on that, or you can just directly scan the QR code and get enrolled and just sign up and log in. You may know that SingleStore has had a free trial offer for many years, but just in the past few weeks, we have announced a new free share tier, which we can talk about a bit later today. So allow me to announce our speaker today. So we have Spandana, who is a product manager here at SingleStore and will be leading this webinar today. So, and we also have Akmal on board, who is going to help with the Q&A or any questions that are related to SingleStore, which Spandana might want to relate to Akmal. So very happy to have you both here, and thanks everyone for joining. I think Spandana, the floor is now yours. Thanks for joining.
Thanks, Yukti, for the introduction. So hello, everyone. I'm Spandana, product manager leading SingleStore Kai and our native pipeline solutions. So today's webinar is going to be a hands-on one too. So you get to explore all the great functionality offered by SingleStore for Mongo developers and see the power in action. So I'll get started with what is SingleStore Kai and why it is important to have analytics on JSON, and why we built it in the first place. And we'll also look at the different benchmarks that we have done to showcase the uniqueness of Kai over other JSON-based databases. And we'll see how one can utilize Kai with their existing database infrastructure. And at the end, we'll see everything in action. So first we'll start with what is JSON and how it has become so widespread recently in the recent years. So JSON is that special format which is easy for humans also to understand and read, and also easy for machines to interpret. And we have seen JSON being used in wide variety of industries like IoT, telco, for analyzing and storing their information like calls, and also for in e-commerce websites, for storing the product related information, metadata, etc. And why everybody's preferring to use JSON? Because we have seen a wide range of developers trying to use JavaScript, and JSON is the easiest data format that is same in both in the app layer as well as the database layer. So, and it is very lightweight. So you can directly work with the JSON structure that's in your app and put the same structure in the database. And so as it has become like internet native format for data transmission. And that's where the popularity of MongoDB rose, because as I mentioned, you can directly get the data from your app in the same format your app understands and put it into the database. So you preserve the same structure like the key values or the nested fields or the arrays, whatever you have in your app, you can have the same structure replicated to your database. And the best part is it doesn't put any schema restrictions. So one of your JSON document can have 5 fields, whereas your sixth document can have, whereas your second document can have like 10 fields. So there's not really a schema restriction. That's why a lot of developers also feel it is very flexible, and it's easy to get started on developing applications on MongoDB. Because in the beginning of an app development, you don't want to focus a lot on how my data is going to look like. You are more open, you are more flexible to keep changing as per your customer needs, right? So that's how MongoDB rose in popularity. And a lot of successful startups have been built on it. It's also a great database. But the challenge comes when you see success, like when your app grows and lot of users start using it and the data volume grows. So that's when the problem arises, because nowadays apps are not just transactional apps, like you place an order or you update or you read something. You have to showcase interactive value and real-time analytics to your users. So take any app, like banking app. So previously banking apps were like just updating transactions and showing maybe my balance. But nowadays, even finance apps, fintech apps are all about showing my spending patterns and also how much I have spent on like food and travel. So everywhere there is analytics that's adding value for customer experience. So all the sectors, not just banking, like e-commerce, take any app in any sector, there is an element of analytics. And that analytics is not about showing a stale data, like it's not showing some yesterday's data. It should be real time, and you have to give options for your users to play with it. Like if I want to see my transactions which are only credits or debits, so I can apply filters or shape my view then and there on the dashboard. So there is a requirement for real-time analytics as well as interactive analytics. And when the user changes it, it should automatically update, right? There shouldn't be any lag, like after 5 seconds, the app refreshes. That's not a desirable experience. So as your app grows, your data grows, and your there would be use cases definitely for any app to show certain analytical use cases for customers. And that's where MongoDB falls short, because it's a great operational database. It can store JSON documents. It can scale really well. If your users are increasing, it can scale really well and store as per your needs. But once you start doing analytics on it, it's not built for analytics. That's why you see that the analytics are really slow, or they use up a lot of your computation in MongoDB database, and which would obstruct your actual operational queries. And that's where the challenges of not able to serve real-time analytics come, because your queries would be blocking each other, and you would not really be able to return the real-time results to your users. And that's when one would look out for other solutions for building analytics on top of MongoDB. And what are the solutions that generally users look for? Because analytics are not working on MongoDB. first thing is easiest one to go about increasing the MongoDB cluster size or increase the nodes. So Mongo also has a concept of analytical nodes, which is nothing but a read-only kind of node, where you would direct all your analytical queries to that node and keep your primary node for all the reads and writes and the quick transactional operations. But the issue here is it's the same MongoDB database structure that's in your analytical node too. So it's the document structure that is not suitable. So columnar structure is the ideal one for analytics, and the document structure of MongoDB is definitely not suited for it. So even if you keep on increasing, it's just about throwing more infrastructure and more money, but the problem doesn't get solved efficiently. That's when users would look out for the databases that are actually built for analytics, which is many SQL-based databases like Snowflake, Rockset, or Elasticsearch. You can see that it's not an easy process to get your data, which is in a document structure, into a database that's SQL only, which is relational. First thing, you will have to change the data structure. You have to flatten the MongoDB document structure and put it into the relational structure of the SQL database. Data transformation is one part, and you would also have to learn a new language, SQL construct altogether. Previously, your app was running analytical queries in Mongo language, like you are building aggregation pipelines with lookups and all the Mongo operators. Whereas now you have to transfer the entire logic, translate that logic into a SQL group bys or joins. So there is a lot of complexity involved, and apart from this transformations, you would have to deploy some infrastructure to do this transfer process. So which is that ETL process. You have to extract from your MongoDB database, transform and flatten it out, and put it into the SQL-based analytical database. So there is a scope for failure, scope for bugs, and it's not really an efficient solution. So that's where SingleStore Kai solves the problem. So as you have seen that there is a data flattening problem, data transformation, and extra ETL infrastructure that's required, and query changes. Your Mongo queries have to be translated to SQL. So SingleStore Kai is a solution for all these problems, because SingleStore Kai is the proxy layer, or the layer that does the translation for you. You need not translate your Mongo to SQL. You just apply the same Mongo queries and to SingleStore. And even though SingleStore is a distributed SQL-based database, still it understands Mongo language. So with Kai, you can safely assume that SingleStore is a Mongo database. So that's as simple as that. You need not do any MongoDB query changes. And you can continue to use all the Mongo tools, like your favorite tools, maybe Compass or Mongosh, or any of these client drivers that are available in almost all the popular languages like JavaScript or Java, let's say Rust. So MongoDB has a wide variety of client libraries, and you can continue to use your apps in the same way. And you need not do any data transformations also. So, and there is no need for an external ETL tool as well. So SingleStore has native pipelines that can keep bringing the data. It's not about just one-time load. You can keep the replication also. You can achieve replication as well with the native solution of SingleStore, which is CDC pipelines. So to summarize, so with SingleStore, which is known for its HTAP capabilities, it being a database that can power both transactions and analytics at the same time, with its unique patented universal storage format, which is columnar, and which can even support high concurrent operational queries, transactional queries too. So that's the unique storage structure of SingleStore that's able to power fast analytics as well as transactions. And with SingleStore Kai, that ability is now open for even MongoDB apps. It's not just for SQL developers or SQL apps. This superpower of SingleStore is now accessible to even Mongo apps. You can immediately switch over to SingleStore Kai with zero code changes, transformations, and keep using your existing tools. And the best part is SingleStore, being a SQL database, understands SQL protocol, and now with Kai, it can understand the Mongo protocol too. So there are two protocols you can work on the same database, which is definitely not possible in any database currently. Either you go via NoSQL route or you understand the SQL language. But with SingleStore, you have the ability to work with any style that you prefer. So these are some of the benchmarks that we have done on a IoT-based data set, which is almost 40 million in size. And all these queries are about the general common queries that any IoT application would need to find. So which is like a count of devices that have sent events, or what is the device that's sending the most events. So the detailed information about the benchmarks is available in the link over there. And you can see that some of the queries. So we have done this benchmarks on the Mongo query. And you can see that the same Mongo query is run on MongoDB Atlas and also on SingleStore Kai. For some queries, we have seen actually more than 1000x improvement. So the queries that were taking, let's say, minutes in MongoDB were done in milliseconds. So that's really crazy. And it's not just me talking, you yourself would be able to see the difference in the later demo that I would present. So ClickBench is another benchmark, which is mostly on analytical queries. And here itself, you can see that the green ones are about the Mongo Atlas and the purple ones being SingleStore. And what another interesting thing that we have observed is it's not just about one particular benchmark run. The results are consistent. Even if you run the same benchmark again and again with concurrent queries running, it's not just about one query in the benchmark and then you proceed to the second query. Even if all the queries are released at once, we are able to see such immediate results returned by SingleStore Kai. So this is just an approximation for getting a similar performance that is possible in SingleStore Kai. If you have to get that similar performance on a MongoDB Atlas, you would have to almost increase your cost by 7x. So you have to beef up your Mongo cluster to that much to serve, to achieve the performance offered by SingleStore Kai. And as a result of you increasing the compute and the size of MongoDB, you would also have to spend a lot. And it's not just about the compute resources that you would be spending your money on, but also the infrastructure required for the ETL, as well as additional manpower that's required for doing the data engineering tasks. With SingleStore Kai, you don't have a need for an ETL or a data transformation. That's why you have a lot of savings even there as well. Now coming to how you can utilize SingleStore Kai. So as you have your MongoDB and your app currently running on it, I hope today's webinar is most useful for Mongo users, and that's how you got interested in the webinar. So I assume you already have your Mongo app and it's serving as your operational database, and you have a requirement of analytics, and that's how you can easily get started with SingleStore Kai. You just need to apply or create this CDC pipeline, which would bring all the data from MongoDB into SingleStore. And you can quickly transfer your application connection string from MongoDB to SingleStore without any code changes. And you can keep using MongoDB as your prime operational database, and you can connect your analytical queries and analytical component of your app to SingleStore. This is one way where you would prefer to not disrupt your MongoDB infrastructure that you already have. The other way would be to totally replace. So both your operational part of the app as well as the analytical part of the app would directly communicate with SingleStore, and your MongoDB would be completely replaced. So to talk in brief, so SingleStore is nothing but a lightweight service layer that does the job of translation. So you can see it takes the Mongo protocol. So it takes the Mongo commands and converts them to SQL, which SingleStore DB database can understand. And once the resultant rows are returned from the engine, SingleStore engine, it would transform them back to the document structure of MongoDB and sends back in the same Mongo protocol to the Mongo clients. So it does the translation to and fro. And we have a lot of customers who have tried it out already. And we have customers who are currently in production and have achieved a lot of savings. So this is one financial firm that had a huge Atlas footprint of almost 150 clusters, and they have a huge workload. Previously, they had to use MongoDB because they were very dependent on the document structure and also the language, the Mongo language, because it provides a lot of functionality and ease of use for working with deeply nested data. And that's why they had to stick to MongoDB. And once they saw the tremendous power of Kai, so they are looking to right now move their entire workload and get rid of their MongoDB. Likewise, we have seen a lot of customers who are trying to consolidate their tech stack, consolidate their database landscape, and simplify, basically not having multiple databases. So one of the customer had Postgres along with MongoDB. Now with SingleStore, their Postgres is migrated, and with Kai, even their Mongo is migrated. So it's just one database that's able to serve the purpose. So that's how we have seen a lot of customers adopting SingleStore Kai. And also, as SingleStore is Mongo as well as SQL protocol compatible, a lot of data visualization tools also work seamlessly. For example, take Metabase or Tableau. You can seamlessly connect using either SQL endpoint or even Mongo endpoint if you prefer writing queries in Mongo language. Yeah, to summarize, we can use SingleStore Kai to augment MongoDB apps for achieving interactive analytics. Augment as in have both Mongo as well as SingleStore Kai, or completely replace and further reduce your TCO. And you can start building new applications, new JSON-based applications utilizing the great capabilities of GenAI offered by SingleStore, like vector search, high-speed vector search, text search, to achieve use cases from hybrid search. And the best part is a lot of tools that makes developers' life easy, like cloud-based shells, cloud-based terminals, notebooks, etc., are inbuilt into the portal, our cloud portal. So you can quickly get started, get your app ready, and start playing with SingleStore Kai. So I'll maybe immediately quickly show how you can get started. I think if you try out some queries and notebooks along with me, you get to participate in the contest that Yukti mentioned in the beginning. So it's simple. You can go to SingleStore website. Let's go to SingleStore. There would be an option for try free on the top. So you can immediately get started, start free. And once you sign up, you would be landing into a page like this. So I've already pre-created my account. So you would be landing into your homepage and your free workspace is ready for you. So you can directly go and explore different functionalities like the developer-friendly functionalities of notebooks and cloud portal, cloud shell that we have. Let me quickly show you what I mean by the cloud shell. So here you can see that this is a shell that's similar to Mongo. You can directly run your Mongo commands. Uh, let's insert some documents. So I'm currently in a database. So database would be pre-created for you. Let me quickly insert some documents. So what this would do is it would create the inventory collection in my database and insert these 5 documents. And you can see that directly from the schema explorer here. So I have the inventory collection already created and the Mongo documents are directly stored. So this is how you can like interactively work with your data, and you can run all the Mongo commands. Like let's say if I want to count documents, how many documents I have. So I have 5 documents, and let's say db dot inventory dot find one. So all the familiar Mongo commands that you can apply here. It's not just about the simple commands. You can run even aggregations and find and modify. So I'm just following a quick start tutorial here that's available on the portal. Even you can get started with that. So this is an aggregate query. Looks like I just inserted 5, right? So it's just giving me the total value. And as I mentioned, it's not just Mongo language that you can use. You can go to the SQL editor that's present in the portal. So you can go to the SQL editor and run commands on the Mongo database. So I had previously the inventory collection stored in this particular database. So I'll first see what are the collections. So in SQL language, it's called tables. So let me run and see that I have. So this is just an internal database that we maintain which is useful for Kai. Now let's do this select count star from inventory. 5. So that's the power I was talking about. You can run SQL queries as well as Mongo queries on the same database. And that's the flexibility that you can achieve, and you can unlock a lot of use cases. Your developers, if they're familiar with Mongo, they need not learn SQL to do great analytics. And if you have data analysts that only know SQL and doesn't really understand Mongo language, you can have the same database. Your Mongo app developers can continue to work in Mongo language, and your SQL data analyst can run SQL queries. So without any transformations and without any ETL involved here. So now let's go to one of the sample apps that's built on SingleStore Kai. Yeah, so I have it here. So this is a simple e-commerce app where you can purchase shoes, and there's a catalog of products here. You can browse any of the products. You can add to cart and check out and make purchases. So this app is currently running on a MongoDB Atlas M30 cluster, and all is well till you are fine with just the operations. Let's say you are building some intelligent features for your users to show intelligent recommendations based on their past purchases or based on the hot selling items. That's when the analytical component comes in. Or let's say you are building some dashboard for the website owner to look at what are the top products that are selling. Then you would have the requirement of running aggregation queries. So that's where we go to the analytics tab and see a sample analytical query. So you can see that this is an analytical query That's basically fetching the top products based on the sales. And this is doing an aggregation based on the sum of the sales. And yeah, so you can see that sum is called, which is the aggregation operation here. And this is the result that SingleStore already returned, whereas Mongo is still taking time. And from our experience, it would take almost a minute. So in the meantime, I can quickly show how easy it is to move the data. So for getting the data from Mongo Atlas to SingleStore, I just ran two simple commands. So which is to establish that CDC pipeline, which continuously replicates the data. For example, what I mean by replication is I'll go to my catalog and place an order. First, let's see the count of orders that are already there. So you can see that the orders are like 37 in the end. Let me place a new order. Yeah, so I have placed an order on MongoDB and the orders have become 38. Same is reflected on SingleStore because we have that CDC pipeline that's continuously replicating the data from MongoDB to SingleStore. And it's very easy to set it up. I don't have the commands right now to show, but you can directly go to our documentation and see how you can get the data replicated. So go to the replicate MongoDB collections. And you just need to run two simple commands here. So one command is about establishing the connection. What's that source MongoDB URL you want to specify? And then the second step is about the collections that you want to replicate. So in my app case, I replicated like three collections. One is like products information, orders information, and user ratings. So you just need to do the simple command and the data would be continuously in sync. Let's see if Mongo has returned. Yeah, I think luck is not on our side. Maybe I can take a look at how Mongo is performing. I have this Mongo Atlas as well. Maybe it's already on a lot of load because I have been switching the tabs and every tab reload, it's trying to, this is the cluster I am using. And I really think it's CPU and memory usage is at all-time high. Yeah, you can see that there's a lot of spike here. Generally, yeah, great. So it returned in 1 minute. Here itself, you can see almost like 100x improvement on this query. Let me run the query again. The best thing in SingleStore is the query plans are cached. So you get the predictable performance and sometimes even better performance than previous runs. Whereas Mongo still takes the same amount of time. Yeah, so this is available for anyone to give it a try. So you have this SingleStore Kai eStore.com. You can make a note or you can post it in the chat. So you can log on to it and establish this connection and see by yourself how the same queries that are running on MongoDB are now super fast on SingleStore. Okay, now I'll jump into how one can build GenAI based experiences on in the same app. So currently my app is kind of basic because if your app doesn't have like AI functionality these days, it's considered basic. Everybody's trying to adopt GenAI and putting in AI based recommendations into e-commerce apps, right? So let me try out a basic recommendation. let me build out a simple recommendation feature into my app. And for trying out that functionality, I can quickly come to SingleStore portal, and there is a place called Notebooks where you can quickly prototype your idea, collaborate with your team, and play with the data here itself till you perfect your idea. So what I'm basically doing is I have created the embeddings for all the products that are there in the website. And I have stored embeddings also into the collection, which stores the product information. Now, I can do semantic searches. So instead of just, let's say, searching for if my website has this, instead of just searching for name-based searches like show me stride-based shoes, I I don't need to force my users to understand what are the products that my website is serving. Let's say a user comes to the website and searches for best running shoes, because that's the experience that anyone is most comfortable in, to directly put their intent into words and not understand all the functionality that my website offers. So I just want to implement that semantic based search into my app. And for that, I have basically created embeddings already using OpenAI, and I have stored the embeddings into my SingleStore database. And I created the vector index. So I have just run this notebook. For in the interest of time, I would not be running it again. But you can see that I have created an index on products collection. And the syntax is quite similar to how you create indexes on Mongo Atlas as well. So I have taken my index type as HNSW and the distance as Euclidean. So here one additional functionality that is offered by SingleStore is you have flexibility in choosing the type of index. So there are multiple other indexing options like IVF. In Mongo, you just have one particular vector index that you create, and there's not really customization. Why would you need a customization? Because your app requirements might be different. Sometimes you want quicker results and you are okay to have, let's say, not like the highest accuracy. Whereas in some cases you want, even though the query, you are okay with the query returning the results slow, but you want the highest accuracy in terms of the closest matches. That's when you can play around with the type of vector indexes and the different parameters for advanced use cases. So I have created the vector index, and so this is the particular search query I want to run my vector search on. So first I am creating a embedding for the search query, and I would do that vector search on this query vector. So let's say user is searching for hiking shoes. Now what I do is I go to SingleStore and run this vector search command specifying the query vector. Looks like I didn't select the database. Let me run it from the beginning. Somehow the results are lost. Maybe I have refreshed my page. Let me quickly run the vector search part because I have already loaded the data. Yeah, so I have the query vector created from this group of words, and I have used OpenAI to create the embeddings. And let's do this simple vector search where you're sending this hiking shoes query vector to the list of products available. And let's print. Okay. So you see that because I'm looking for top 3 results, I have 3 results here, and maybe it has picked because there's some hiking here and jogging. So it's not just matching for particular word like string like hiking shoes. It's looking for all the products that are matching in the similarity with respect to the meaning or the intent. Yeah, so trial adventures. So with this, I am able to achieve that basic use case that I had in mind, that ability to give users to search based on natural language. But sometimes it's not just about showing the top results. Users would also want to know, like, how popular is this brand, or what are the reviews for these products. Just by looking at the top 3 suggestions, even we don't purchase products, right? So we go into the products, we'll see how the users have rated it over time and what's the popularity, how are they selling. That's where SingleStore Kai's power becomes even more necessary, because along with vector search, you can combine that result instantaneously with an analytical type of pipeline. So in this aggregation pipeline, I am getting the top 3 results like before. And on those top 3 results, I am also fetching the additional information like the total sales. And this particular query, even though it has a vector index, which would be fast on MongoDB as well, and later comes the analytical part. That's where Mongo suffers, because it can't do that huge computation on a lot of documents at the same time. You can see that even this returned quickly, and along with the top 3 products, now I have the total sales. Now I'll be able to give like richer information to my customers. I can show the top 3 recommendations, as well as I can show this information about what the total sales of this product. And this is just a simple example that I wanted to illustrate. And you can start building all these intelligent use cases into your apps, and do these hybrid type of searches. You can combine vector search with text search and enhance that with analytical components. Everything you will be able to do in SingleStore, because it's a multi-model database. You can leverage the power of vector search, text search, and the fast analytics on it, as well as the JSON capabilities that are available with SingleStore Kai. Now, what I have done is I simply ran the same query on MongoDB as well as SingleStore, and took the average like 5 times. So I've already run it. It plotted the result here, and you can see that SingleStore's query time is like quite less. It's like it's in milliseconds, whereas MongoDB took almost 6 seconds to run this. Maybe I can quickly trigger it as well. As it has to run the query like 5 times on SingleStore as well as Mongo, this particular cell in the notebook takes time. SingleStore would definitely return in milliseconds, because you can see that each query took like time in milliseconds. So it's the MongoDB that's adding the time here. And I think it should be done in 30 seconds. Yeah. So no matter how many times you repeat the experiment, it's always SingleStore here winning. So I have the same data that's in SingleStore and MongoDB, same number of documents and the same vector index, and no other further indexes that are built on SingleStore. It's just the vector index, and that itself is able to achieve such high speed. Even without indexes, you are able to achieve such high speed on your analytical queries. So this is also a great advantage, because you can't keep on adding a lot of indexes based on your query. Sometimes you want to do an analytical query based on your product ID. You go and add index on product ID. Sometimes you want to do a query based on the date to see how the sales trends have been over date. But you can't continuously keep on adding indexes, because that's a lot of overhead that you add in case of MongoDB, because every insert is going to be affected. It's going to get slower. And also, it's not easy to maintain a lot of indexes, because if that's a practice that you tend to follow, then that's the easier solution that you would look for, and the number of indexes would be numerous. And another problem is if you have a lot of indexes, it would take up the RAM, and because entire index has to be in memory, that would even disrupt your concurrency and the queries that MongoDB can serve. So adding a lot of indexes sometimes is not the solution for powering the interactive analytics. So this notebook also would be available for you. Currently, it's in my workspace, but I can put it in GitHub and share the link with Yukti. So all the participants can get access to this notebook. Yeah, so that's all I had to share for today.
Thank you
I
so
would love for all of you to give it a try. It's easy. Go to the website and click on Start Free, and you have a forever free tier for you to build your apps and explore all the fast analytics and the GenAI vector capabilities of SingleStore.
Thank you so much, Spandana. That was such a cool demo. I mean, even I'm very curious, like, how does SingleStore look like under the hood that it's able to outperform Mongo like that? It was actually insane what I saw on your screen.
Yeah, so the main, I think the capability that I can talk about is there are a lot of optimizations that we have built to support such high concurrent analytical workloads. The one thing that would stand out is our universal storage capability, where we have that ability to, which can handle fast inserts and updates and all these transactional type of operations, as well as the analytics because of our unique columnar storage.
That sounds really interesting. So, we have some questions. I mean, Akmal did take like good care of those questions. Thank you, Akmal, for that. So, similar questions like, how much programming languages we can use here, and yeah, Akmal, you see your hand raised there.
Yeah, I was going to just ask, I think there was a question, let me just try and find it, from Fahad. He was asking, could you please, how to correct data? Spandan, I think that was part of your presentation. You talked about that maybe. So I wasn't quite sure what he's referring to. But it's, I think, taking data, say, from Mongo and getting it into SingleStore. I mean, there is a process to do that, either through ETL or using the CDC tool, for example. But the data itself is, I mean, the format that you're reading it in, for example, JSON is JSON. Whatever errors exist in the Mongo environment will also exist in the SingleStore environment. I mean, that's something you, as an analyst or a developer, would have to clean up before you bring that across. But I mean, you could do that in SingleStore too. I mean, it just depends on where it is easier. So I'm not quite sure what the question was, but I think that question was lingering for a while. And Yukti, maybe you've just kind of parked it away there. So
Cool. So it's open for questions if any of you have questions. So we have almost 5 minutes here.
Yeah, absolutely. You can use the Zoom Q&A button, which is present at the bottom of your console. So if you have any questions, feel free to ask them right now. And Akmal, thanks for taking care of these questions. And so we have one question from Lucas. They say, what is the max value for the distance when we are querying for a vector?
Okay, so that maybe Akmal, you can add. It depends on the distance metric. For Euclidean distance, I think the range is from 0 to I think infinite based on the distance. Whereas if you talk about the cosine similarity, it should range between -1 to 1.
Yeah, I think for these distance metrics, the two that we support out of the box are the dot product and the Euclidean distance. And those are fairly standard. I mean, our implementations follow however you would, in terms of distance metrics, however you would evaluate those and use those. There is no change there. The question that sometimes gets asked, is there any limit to the number of dimensions that SingleStore can store in terms of the vectors themselves? And as far as I know, no, there's no limit. up to, within reason. I mean, eventually you'll run out of space, okay? Because if you're going to store something so large, the system is going to run out of storage space, but within reason. If you use like 1536, which I think is what OpenAI uses, what was the number of dimensions you used in your demo, Spandana? I wasn't quite.
I think it's I used a embedding model of
Was it 1024, something like that?
yeah. I used this embedding model, so I think it's yeah,
Somewhere there should be the number of
yeah,
dimensions. Oh, there you
153.
are. Yeah, 1536. Yeah, that's right. That makes sense because it's an OpenAI. So these are text embeddings. So that's pretty reasonable. But as far as I know, I mean, we don't impose a limit on the number of dimensions architecturally. I mean, but it's highly unlikely you're going to use millions of dimensions. Let me put it that way. Just my assessment.
Oh. Do we move on to the next question? Because we have some questions from people, if you allow me.
Yeah, go ahead, Yukti. I think
Oh,
I'm not
right.
able
So
to see because I'm sharing the screen. I am not able to find the
no
question.
worries at all. So yeah, that's what I thought that I'd rather help. So there's a question from Akash. They say that he was trying to run a notebook which requires an OpenAI API key. So do they need to use their own API key or is it provided for the free demo?
So for this particular notebook that I showed, I have actually used an paid OpenAI key. So there's an interesting feature that's right now in development where we are planning to expose an embedding model in our free tier. So you can get started with all your GenAI ideas and without spending any penny. Yeah, so that's going to be out soon.
Thank you for that one. Okay, so I see that Akmal is already taking care of this question, but there's a question from Andrew that how can they use this for big data analytics or for larger data sets?
Yeah, so like SingleStore can scale comfortably up to petabytes of data. So all kinds of big data you can comfortably run. And the best part is generally big data analytics is in the scope of SQL till now. But the thing is you can run Mongo query on a big data. So you can run that aggregation pipeline on like terabytes of data, which was not possible before.
All right. So it seems like we don't really have more questions, so we can wrap up with a few quick notes before I announce today's raffle winner. So we have amazing sessions that are coming up, and I would love you all to join and just tune in with us. And on August 1st, as you can see on your screen, we are presenting, that webinar is rescheduled. So on August 5th, we are presenting the Trillion Row Crowd DB speed test. So as Panna said, we can handle very large workloads. So we'll actually put SingleStore to test and actually test its actual limits. So if you want, you can tune in with that. You have the link on your screen and it's there in the chat as well. So on August 7th, we have Elevate Your AI Apps with database branching. So if you're interested in that, we have Mohan, who's from Spandana's team and is going to speak with us. And if any of these topics are interesting to you, please RSVP right now. And I hope to see you all there. So the announcement that you have been waiting for, today's raffle winner, it goes to Rachel Wu from Meta. She's an ML engineer there. Congrats and thanks for joining, Rachel. That's not you. Do not give up because we are going to announce one more AirPods and Meta's Ray-Ban winner by the end of the day for anyone who has tried out today's demo. You can just sign up at the link that's present on your screen and be entered and just be eligible to win. Thank you so much, Spandana, for such an amazing demo. I wish that we can bring similar stuff again. We can explore more things. And thank you, Akmal, for joining. And thanks everyone for tuning in for from wherever you are. Have a good day. Have a good night. Take care, everyone. Bye-bye.